Thank you and welcome everybody. My name is Simone Zamboni and I'm a research engineer at Embark. And today I'm going to be talking about how to make video game characters come alive with language models. But first I will just go to a very quick introduction of Embark Studios. It will be very short since my colleague Ali yesterday already gave a very quick presentation. So we are a video game studio founded in 2018 by industry veterans from DICE. And the idea of our founders was to create a studio that will push the boundaries of creativity. We are based in Stockholm, and we are around 300 people today. So what are the games that, in our opinion, are pushing the boundaries of creativity? The first one is called The Finals. It is a team first-person shooter, and it is very fast-paced. What sets it apart from other games is the level of environmental destruction, which is quite insane. And it is free to play, and you can play it right now. And here, just a very quick screenshot of the game to see how chaotic it can be. Another title we are working on is called Organised. It is a game with a third-person view, and it's player versus environment. And the idea is that there is a very big world to explore, which is full of loot. And there are maskless synthetic enemies that are trying to attack you before you get the loot, but also other players in which you have to decide to collaborate or to fight. And here is a promotional image of the game, since it is not out yet. However, we are also working on some much more experimental projects, and we have one called Embark Creative Playground. So this is a very, as I said, experimental project, and it's also like a test bed, and we can test different technologies that we are developing. The idea is that at the end, all of these technologies should come up to have like a multiplayer online universe with a lot of focus on the social interaction part. And it should be very playful and cozy, as you can see from the image on the right. And here another image of the game. You can see like very colorful, very saturated, full of like characters that are talking with their speech bubbles. However, today I'm going to be focusing about just one aspect of our creative playground, what we are called creatures. So creatures are the non-playable characters of our playground, and they are aware of their surroundings. They move around in the environment, and they're able to verbally react to events and converse with the player. And they can do all of this because they are powered by AI. And so yesterday, my colleague Ali explained to you how we use reinforcement learning to make these characters move. However, today I'm going to be focusing on how we use language models to make these characters talk. As you can see here, there is an image of one of our characters that we call the seal. And it came near to a lantern, and it is reacting to it. And that our characters are also able to converse with a player. And the fun thing about talking with these characters is that you can ask them whatever you want, and they will try to answer to you as best as possible in real time. And so I have a video to show you what it means to interact with one of our characters. So yes, I hope it was nice to see how we can interact with our characters. As you saw at the start, the seal was going around, and you noticed like the big tree that you can see here, and he interacted to it, and he said, "Oh, what a sight to behold!" And then, as you saw, I started speaking with the seal, and he called me by my name, Simone. So he knew who was I. And also, as you saw, I could just like type whatever I wanted. And the character will react in real time and try to respond in real time to whatever I ask it. So this is very different, as you imagine, from what you usually do, from how you usually interact with video game characters. So usually, every interaction that you have with a video game character is scripted, which means that there has been somebody that has beforehand written every single line of text that a character can say to you and that you can say to the character. And this might be an issue sometimes because they can be like what they are talking about, these characters, they can be literal relevance to what is happening in the environment or what the player has done. So let's say you're talking with a character and there is like a massive monster behind the character destroying everything. If that character was not programmed explicitly to take into account the situation, they would just say, oh, what a nice day, which is it kind of breaks immersion. And also, for example, you might have a city that the player has saved, and if the characters in this city are not specifically programmed to like hail the player as the hero of the city, they will just treat the player as normally. And so we think that this situation can kind of like break the immersion when you are into a game. And so what we would like to do is to use AI to generate the interactions in the fly. And as you can see before, we are able to do this, and in doing it in this way, our characters can react dynamically to changes in the environment. So for example, at the start, the seal reacted to a tree. Well, there might be, for example, I don't know, like a table, and they might react to that table being there, or I might be called by a different name and ask different things, and they will react, and they will be able to talk with me, whatever thing I asked. So I would like to spend some time to talk about how do we actually do this. And we're doing this using language models. So language models are a type of deep neural network that can generate text. So they work by getting text as input and then outputting some text. So you can see in this case, we have the input text is I really like. We give it to the language model, and it will output something like pizza. And they usually train these models to predict the next word in a text. And you can think about them as the autocomplete on your phone keyboard. So if you take your phone keyboard, you can just press the word that they suggest to you and continuously press it. And you will create a sentence. It is probably a sentence that doesn't make a lot of sense, but it will be like a sentence. Well, language models work exactly like that. And in fact, the most famous language model of all, ChatGPT, works exactly like that. The difference between the autocomplete on your phone keyboard and ChatGPT is that the autocomplete on your phone keyboard was trained on just your text that you sent to your family and friends. However, ChatGPT was trained on whole parts of the internet and literally trillions of words. And another added benefit of language models is that they are probabilistic, which means that each response will be different, which is great for us because it means that every interaction that you will have with our creatures will be different. I would like to delve a little bit deeper in the difference between like the autocomplete on your phone keyboard, which I think is a very useful comparison, and bigger language models. And but to do this, I would like to tell you that deep neural networks, and as we said, the language models are deep neural networks, they can be described with numbers, and these numbers are usually called parameters. And as a rule of thumb, you have that the more parameters you add, the better results you get, so the smarter your model will be. However, the more parameters you add, the more computationally intensive it is to generate text. So you will need to add more compute or to wait longer for the generation. And there is also to consider that deep neural network can run much faster on GPUs than on CPUs, so they're quite expensive to run. Just as an example, I would like to show you a family of language model, which is called GPT. So you can see here the first GPT, GPT-1, was released in 2018, and it had 117 million parameters. GPT-2 was released in 2019, and it had 1.5 billion parameters. And ChatGPT, the first version in 2022, had 175 billion parameters. Just yesterday, Meta announced that they're training a language model with 400 billion parameters. Now, just to give you a sense of like scale, these neural networks, these language models that are deep neural networks, as we said, they run on the GPU. So all these parameters need to be loaded in the GPU. And as a rule of thumb, you have that 1 billion parameters occupy 2 gigabytes of GPU RAM, which means that GPT-2, with its 1.5 billion parameters, will occupy 3 gigabytes of GPU RAM, which is heavy, but you can still run it on your laptop probably. However, when you go to this site, 175 billion parameters, it means that you need 350 gigabytes of GPU RAM. So if you take the RTX 4090, which is the most powerful consumer graphics card that you can buy, you will need, it has, I think, 24 gigabytes of GPU RAM. So you will need 15 of them to run a single instance of ChatGPT. And that is why the models that power our creatures are not as big as this, because we will go broke. And it is something that we would like to avoid. So they're much closer to this one. So we can more easily run them. And also, as I said, that these models are very heavy and they require GPUs. Usually when you have it into products or into games, for example, you don't run them locally. We have a client that just asks for an API to a server, and the server actually runs the language model. And so if you say, oh, I have a product that I would like to integrate for example, a game, that I would like to integrate my language models in, and you're saying that I just make an API request to another server, why can't I just plug in the language model that somebody already has done? And you can definitely do that. For example, you can use GPT-4, which is arguably the best language model out there. But in our analysis, we found a couple of potential issues that you might encounter. So these language models, as we saw, that they require a lot of computation. They are quite expensive to run. So if you think about that, let's say that every time that you ask GPT-4 something, it costs 2 cents. Well, if you have a user, if your average user does 200 requests per month, now this user is costing 4 euros per month. That's a lot of money for just a feature of talking with our creature, for example. So using these models can be very expensive. And also they can say tomorrow, if you use a third-party vendor, for example, OpenAI, that creates GPT-4, they can say tomorrow, oh, we change our license and you cannot anymore use our model in your game, for example. Fortunately, there are many competitive open source models out there, and you can find a lot of them in a website called Hugging Face. And so our approach was that we take an existing, smaller open source model and we train it on our data. This is, of course, much complicated than just using GPT-4 with an API, because you need to have engineers like me that are training the model and deploying it. However, we think that in the long run, this might give us more control and it's going to actually be cheaper. So now we talk about language models in general, and now you say, OK, I understand how language models work. Now, how do I put them into a game? And you will run into an issue pretty soon, because as the name implies, language models work with text. So they get text as input, and they generate text as output. However, our creatures live in a 3D world. So how do we make the 3D world and the language model to communicate? Because we want to ground our language model based on what's happening in the 3D world. We want our creatures to react to what is happening around them. Well, we came up with a solution to create a text representation of the world from the point of view of the creature, which will be the perception of the creature, and then create a text representation of the internal state of the creature, which is like its self-awareness, one can say. And so you can see here one of our creatures, Burgerman, going around. And while it goes around, it queries objects around it. So we might have like an egg, a table, and a cake. And we can also add more information about this object, like the egg is purple and rotten, and so on. And we collect all of this data, and this will be the perception of the world of our creature. Then we try to add some information about the self-awareness of our creature. So for example, what its name is, if it is healthy, hungry, what is its appearance, what it likes, what it dislikes, what are its social relationship or its role. And once we have all this information, we just put it together and we pass to a text compilation, which is just taking some strings and filling in the blanks, basically. And we generate something that we call the context, which will be all the information about the perception and the self-awareness of the creature in a text format. So you can see here, after our text compilation, our context might be, my name is Burgerman, I feel scared, I am near a tree, and I am speaking with David. So this is the context that contains information about the perception and the self-awareness and its text, so we can give this text to the language model. And this leads us to our dialogue system, which is composed by the context that I just explained, and then simply the conversation history or the text format of events. We put them together and we give it to the language model. And then the language model will output an utterance, so what the creature will actually say, and an emotion. And the emotion is used to change the facial expression of the creature. So we can see here an example. We have a creature which has a context. My name is Salamander. Yeah, I am at full health. I have a green box and a stone behind me. And it got an event that was, I was stuck, but now I'm not stuck anymore. We give this to the language model, and the language model might say, yay, I'm no longer stuck. This is amazing news. Let's go explore the world around us and see what else we can discover with the emotion surprise. And you can see here other examples of creatures reacting. You can see on the top left a creature reacting to a player called Miso, which is jumping. And it says, whoa there, Miso, that was quite a jump. You're an impressive jumping machine. Or like another creature that is starting to feel hungry, and it says, I'm starting to feel very hungry. Do you know any local food places around here? Maybe there's something I can eat. And you can also see the facial expression in the two cases is different because of being hungry is a less pleasant situation. So also the emotion that decides the facial expression is decided by our language model. And you can see here an example of a conversation in which you will have our character, which has a context. My name is Burgerman. I'm near a tile on a green floor. I just spoke with a stranger. I'm speaking with Simone. And I ask it, hi, how are you? And the language model might say something, I'm doing great. I just finished speaking with a stranger, and it was so nice, with the emotion surprise. And this is one of my favorite examples to show. This is a player just asking to one of our creatures, like, what do you think about Embark Studios? And the creature is saying, I'm actually not very familiar with Embark Studios. As far as what I do, I'm not a professional player or anything like that. I just like to go and play my own games. So I hope this example convince you how flexible and powerful our system can be, because it will be very hard for somebody to come up with every single possible question that a player could ask to our creatures. That would be a very complicated and tedious process, and you would certainly miss something. However, with our approach, the players can just ask whatever they want to our creatures, and the creatures will do their best to give a response that makes sense, but it's also sometimes entertaining. Until now, I have talked about language model for interacting with characters. However, we started to explore also another another way in which we can use language models, and it is to manipulating a game. Because language models output text, but of course, code is also text. So in fact, you have products like GitHub Copilot or Roblox Assistant that they help you write code using the language models. And the idea is that we would like to give a much more refined version of these tools to our players because they probably don't know how to code. And the idea is that we will have a language model take instructions from a player and then output the code to generate the instructions. And to make this work, we will need a scripting language, which are usually done in Lua, Python, or JavaScript. And then the language model will need to know the specific scripting language that it is in our game. Because let's say you ask the language model, OK, create a tree. Then it needs to know what functions to call to create a tree. I need to call the create function, and I need to pass the parameter tree. And then the code that the language model creates, it then gets executed in-game by real time. So if you put all of this together, you will have something like this. Yeah, so that was basically everything I wanted to show you today, and I hope I convinced you that we can use language models to create video game characters that really feel alive and that they can respond to everything you say to them. And also really hope that I showed you how one can use language models also to give immersive creative power to the user. Of course, it is not easy, and it not always works as intended. And the degree of control that one has on language models is much more limited than the degree of control that one has in more traditional game developing tools. However, we really think this has the potential, at least, when the technology will be more refined, to be a paradigm shift for games. So thank you very much for your attention. And if there are any questions, I'm here.
I have two questions. I think the first one you'll be able to answer very quickly, which is why do the characters seem to have difficulty capitalizing proper nouns like names?
Yes, so I guess it has to do with the fact that they've seen a lot of text, and sometimes people capitalize names and sometimes they don't. So they have learned that sometimes they do it, sometimes they don't. It's something that probably a more bigger and capable model than our will be able to do much better.
Okay. And the second question is a bigger question, but what kind of a framework do you think would be required to provide characters in a game that can respond as if they came from different cultural or socioeconomic backgrounds?
Yes. So if you saw before, there were a slide in which we added some information about the self-awareness of a creature, right? So what the name of the creature is, and inside there, one can add some information about the socioeconomical or the background of the creature. So for example, you can say to a creature, oh, you are, for example, like a bartender into a bar, and you should behave like that. And these language models have been trained on huge amount of text. So they already know a little bit how, for example, a bartender might behave. So they will start to behave like a bartender. So you basically can, with just some text, you can condition the language model to behave in a certain way. One thing that I personally tried, in the self-awareness, I said to a creature, oh, you are a very unfriendly and mean person. And I started talking with this creature, and it was like, you have a bad name, it told me. And then it told me, please stop talking with me, you are bothering me. So you can really condition them to behave in a certain way.
I guess I really mean what about really, really marginalized cultures that may not be part of the overall corpus?
Yes, in that case, if you really want to do that, what you need to do is to gather some data about text written in those kind of situations, and you'll have to further train your language model on that data. And then, hopefully, the language model should be able to behave like you want. So you can just train it more on what you want. And this step is called usually fine-tuning in the machine learning community.
Hi, thanks. It was a very interesting presentation. At some point, you showed that the AI, it can very easily spawn cards. You said the command spawn some cards, and it spawned something similar to photographs. When I saw that command, I was more thinking something about playing cards. And it's a text interface. How I would at least text to my friends in order to correct something like that. I would simply send them playing cards and asterisks afterwards or before that. Are you maybe thinking of adding something like that where you can add in these little asterisks as a correction to maybe a previous command?
Yeah, I mean, so you would like to basically customize some command and send it to your friends. That is my understanding.
Kind of replicates that more similar, like how you would correct a text to your friend, kind of replicate that in the system.
So you could definitely do that, but it should be in the training step, so before. So once you're teaching this model how to write the code that you want, you could look at the output of this model and say, then you can add corrections basically back to the training data. So this will be a step that you do before, in which you are teaching the language model how to behave correctly.
Hi. So if you're going to use it in a real game, how do you prevent your characters from falling out of character? Like if you ask them about Elon Musk or something like that, like how do you prevent them from answering honestly like Elon Musk is a billionaire, blah, blah, blah?
Yes. So one thing that you can do during the training phase, you can provide examples of how these characters should react to user questions. And you can show them example of like people asking, what about Elon Musk? And have your character say something like, I don't know who Elon Musk is. However, it is not a 100% like foolproof process, so they will sometimes go out of character, and this is really hard to control. One thing that we can say is that in this case, like a user asked, who is Elon Musk to a creature? Well, in that case, I think the user also has to like expect that probably a question like that might have the characters go out of character. So it is definitely an issue, and you can also do with ChatGPT. You can like fully to tell you whatever you want. So it is a bigger problem in the space, and it is not fully solved yet. So you will have up and downs. Sometimes our creature will respond really well, and sometimes not. They will go out of character. It will feel weird.
We have time for one more question.
I think.
Let's pick this side now.
Hi, thank you, great talk. So sometimes these ChatGPT things, they tell you what you want to hear. They're sometimes like, they feel like motivational speakers or yes men. But I'm interested in more like controversial topics and hot takes. Can you also get the character to challenge the player in that way?
Yes, so how this language model works is that it tries to predict the next word, right? And so you give them some text, and they try to predict the next word. And so what you can give to them is like examples of the behavior that you want them to have. So for example, let's say you want to have characters that respond in a mean way. You will give them like a conversation about like your creature and a player and the creature being very mean. Or you can do this with let's say you want your creature to talk like a pirate, okay? You will just give it a lot of examples of it talking like a pirate, and it will learn how to talk like a pirate. So like the powerful things about language models is that you basically give them some training data, and it will try to behave like it was like the training data. So the most important step of my job when I train these models is to change this training data to something that we like. So then the model will behave in the same way of the training data, and this is the way that we want our model to behave. So like 99%, like the vast majority of my work goes into the first step. And then hopefully everything works out. Yeah, so thank you very much.